49 light-years from Earth, two planets orbit the same red dwarf star. The inner world is hot, dark, and probably completely airless. Farther out, however, lies a frozen super-Earth that has retained its atmosphere and may hide a vast ocean beneath the ice. The same star. Two completely different fates. This is the LHS 1140 system, with LHS 1140b at the center of our story. The system lies in the constellation Cetus, approximately 49 light-years from Earth. At its center is a red dwarf with only about 1/5 the mass and size of the Sun. The star is more than 3 billion years old. It rotates extremely slowly and is relatively quiet compared with many other red dwarfs. Powerful flares appear to be rare, but the star still produces X-rays and ultraviolet radiation. Over billions of years, this radiation can gradually strip away the atmospheres of nearby planets, and the system's two known worlds orbit at very different distances from the star. The inner planet has a radius about 1.3 times that of Earth and almost twice its mass. It orbits so close to the star that 1 year lasts only 3.8 Earth days. It receives approximately 5 times as much energy as Earth receives from the Sun. Its surface is probably dark, hot, and almost completely exposed to space. Astronomers have found no convincing evidence of a substantial atmosphere. They also detected no escaping helium around it. The inner planet may once have possessed an atmosphere, but radiation from the star could have gradually removed it. The outer planet, however, orbits much farther away. Its year lasts almost 25 Earth days, and it receives only around 42% of the energy Earth receives from the Sun. This places it within the star's habitable zone. The planet has a radius approximately 1.7 times that of Earth and is about 5.6 times as massive. Measurements show that it is less dense than a super-Earth made entirely from rock and metal should be. Water may account for between 9 and 19% of its total mass. Because its estimated equilibrium temperature is around -47 degrees Celsius, most of the surface is probably covered in ice. The planet is also expected to keep the same side permanently facing the star. Climate models suggest that enough heat could accumulate in the region directly beneath the star to melt part of the ice. This could create a circular ocean approximately 4,000 kilometers across on an otherwise frozen world. But for this ocean to exist, the planet would need an atmosphere capable of moving and retaining heat. In 2024, the James Webb Space Telescope studied the planet as it passed in front of the star. Webb ruled out the enormous hydrogen-rich atmosphere expected around a mini-Neptune. Instead, the data suggested an atmosphere made from heavier gases. Possible traces of nitrogen also appeared, although the signal was too weak to be considered a confirmed detection. Later, the Magellan Clay Telescope in Chile observed both planets during the same night. No helium was found around the inner planet. Around the outer planet, however, astronomers detected helium escaping into space. Some of the gas even appeared ahead of the planet along its orbit. The helium was not detected again in 2025, suggesting that the strength of the atmospheric escape probably changes over time. But the escaping gas provided clear evidence that a more substantial atmosphere still exists below. Around the same star, the inner world may have lost its atmosphere, while the outer planet managed to retain its own. This is what makes the entire system so remarkable. The two planets formed around the same star, yet they appear to have reached completely different outcomes. The smaller inner world receives intense radiation and has probably lost its atmosphere. The outer planet is larger and colder, and its stronger gravity holds atmospheric gases more tightly. It also lies in the habitable zone, may contain enormous quantities of water, and is now known to possess an atmosphere. But this does not mean that the planet is truly habitable. Its possible ocean may remain completely frozen, while its atmosphere could be too thin, too thick, or chemically hostile to life. Future observations must determine which gases it contains and whether liquid water can truly survive on its surface. Around one quiet red star, two worlds tell two completely different stories. The inner planet moved too close and may have lost almost its entire atmosphere. The outer planet retained its own and may even have protected an ocean beneath the ice. Only about 10 million kilometers separate their orbits. One is probably a bare rock. The other may be one of the most promising, potentially habitable worlds we have discovered.